Hi everyone, welcome to this week's DevOps Chat. Really delighted to have with me today Dustin Kirkland from the US. He's going to be presenting and also running a workshop at Container World next week. But before we get on to that, Dustin, perhaps you could start by giving us a little bit of information about your background and what you've worked on in the past.
Yeah, sure, David. So my name is Dustin Kirkland. I'm responsible for Ubuntu product and strategy at Canonical. So I've been around open source for almost 20 years now, and with Canonical working on the Ubuntu server since about 2008. Ubuntu really burst onto the scene from a server perspective in 2008 as we put Ubuntu into the Amazon public cloud and then into every other public and private cloud you can imagine. My background's a developer. I still write a little bit of code on a daily basis, but a product manager is really my work responsibility. Containers are near and dear to my heart. I've been working on and around LXC and Linux containers since my IBM days. We've been maintaining the Linux subsystem for containers LXC at Canonical since about 2010. So we're going on 7 good years of experience around containers. We also work real hard to make sure that Ubuntu is a great platform for all container types, including Docker and orchestration like Kubernetes and others. So next week at Container World in Santa Clara, I've got a session on Wednesday at 1:30 p.m. Where we'll take a survey of all of the different container technologies available on Ubuntu. But Tuesday, if you're around a day early, come and join us for a 90-minute hands-on workshop. Bring a laptop and internet access, and I can guarantee you everyone who joins us for that session will have deployed a Kubernetes for their own use, either to a public cloud or to a local machine to their laptop if they want.
Fantastic. I mean, it's the kind I really wish I was going to be there when you talk through both what you'll be presenting, but also particularly that workshop. And just maybe it'd be interesting to take a step back and talk a little bit about containers. You've been involved with them for a long time. I mean, I think it's 15 years ago, it was unimaginable that you might be able to go to a workshop and, as you say, 90 minutes later have deployed multiple instances of something in the cloud or even on a local machine. And that's completely transformed, I think, partly the way we can deploy software, but actually the way we can develop software as well. So what are your views on that? I mean, how do you see that containerization has really impacted how software is developed and deployed?
Yeah, containers have been just such a part of my workflow for so long. It's actually a little bit difficult for me to think back to a time before containers. But I'll try to do so, I mean, maybe in a way, perhaps you take virtualization for granted, or there's certainly a generation of developers who will take virtualization for granted. Maybe you and I are old enough to remember needing a Linux server, and that process involved putting a request into your procurement to have a server purchase, which might get ordered and shipped in 6 to 8 weeks, and then it sits on a pallet and someone has to unbox it and rack it, and now we don't have enough cooling or air conditioning for that server, so we're going to wait a bit longer. All this time, your workload is still on hold, or your project, your program is still on hold. Eventually that machine is racked and stacked, and you get an IP address and your keys installed on it, and then you can deploy the workload. Today that's a 60-second process against any one of the public clouds. Give me an Ubuntu 1604 64-bit Intel instance, and you can do that against Amazon and Azure and Rackspace and Google and wherever else. But if we take that even another order of magnitude and we think about how quickly you can launch a container, perhaps locally or perhaps in a cloud, in the sub-second time frame, the time that it takes to provision a new instance, the same instance of Ubuntu 1604, but inside of a container, or you want to deploy that process directly into a Docker container, that's a fraction of a second now. And so from that perspective, yes, things have changed. It's just such a part of my workflow. It's hard to think about. It's hard to remember what it was like before that.
And I mean, is that because it came up during the last DevOps chat when we were talking about containerization, this whole kind of, yeah, but what's new? Why is it really different? And is that part of it? Is it that is the key to this that it's orders of magnitude difference in terms of speed? So we're not talking about it's a little bit faster. It's actually so much faster that you can completely change how you work or how you scale an application.
It is game changing. I think the lack of people who aren't necessarily impressed or don't necessarily see the fundamental change is because containers and the container technology has been around for so long.
Mm-hmm.
BSD, JLs, or Solaris zones, LXC containers. Docker even now is 4+ years old, right? So there are people who come to this more, that have been around this for a while, and see people who see this as completely new, and it's maybe less impressive. But it is, as you said, it is a whole step function change. It's an order of magnitude difference. It really comes down to one fundamental concept. And it's an old concept, but it's the concept of having a single operating system kernel, a single Linux kernel, and having spaces wrapped around processes or applications or even entire operating systems. And yet it's still sharing the same kernel. That's the key difference between containers and virtualization, is that with virtualization, you're running a different copy of that kernel in every single virtual machine.
Yeah.
And there's some advantages to that. There really is a emulated hardware layer that separates the guest from the host. And there's a reason why you might want that. If you want to run a Windows operating system on a Linux guest, you need to emulate that entire hardware infrastructure. But for scale-out workloads and modern workloads, almost any modern web service or online service that you use is backed by pools of Linux machines. For those Linux on Linux workloads, if you don't duplicate that kernel over and over and over again, you can take tremendous advantage. It is orders of magnitude faster. You can put orders of magnitude more of these instances on a machine than virtual machines. So it is a significant change. And because of that, we've developed new programming models. There's a different way that a modern developer writes an application to take advantage of what containers bring them. Compared to what you and I might have done a decade or two ago when we wrote whatever we were writing in 1997, probably Java.
Yeah. So go on, say a bit more about that. So what is it? What is the impact then of having very lightweight containers and being able to spin up lots of them in parallel? How does that change, or what's the development approach then that takes advantage of that?
So there's a couple of terms that people use when they talk about the new style of programming. They might say they might talk about microservices. They might talk about cloud native. They might talk about 12-factor actually. And I'll go into all three of those in my talk at Container World and give a brief overview of each of those. First one, the concept of microservices is actually, again, a very old concept. We might have called it service-oriented architecture. Certainly, if you were writing Java apps against IBM WebSphere 15 or 20 years ago, you were using this, where you were deploying one application server to handle one piece of a flight reservation system or something like that. Okay.
Yeah.
So in a sense, we've kind of rediscovered what was a best practice when using a framework like WebSphere some time ago. Now, actually, what has happened in the meantime, or in the time since, is we've instituted a new technology in the Linux kernel that we can take advantage of when deploying a microservice. So in a microservice architecture, each container does one thing and one thing very, very well, right? And when it doesn't do it so well, you kill it and you start another one just like it, right?
Yeah.
If you design your application to take advantage of that microservice architecture, there are a lot of benefits you can take advantage of in the container world, right? Yep. When we talk about 12-factor apps, it's sort of a development methodology. It's an ideology, I guess, where each of those factors, in a way, helps your broader application become more robust, become more maintainable, more secure, more highly available, more compartmentalized. From that perspective, you can look at each of those, the factors, and most of them actually map to constructs in containers, in fact. And when you do that, you can actually use containers to help you meet the requirements of being a 12-factor app, right? Cloud native is another similar concept. They're all within that same realm. Cloud native is a methodology where the application, as you're developing it, maps to constructs that we're familiar with in the cloud world. And once again, containers now becoming inextricably part of every cloud fits into the cloud native landscape very neatly, and it solves a number of problems that you would want to address when building a cloud native app.
And would you say, I mean, because certainly I've looked at 12-factor app, and I think that part of the benefit there is that you get a lot of things like scalability, like robustness, thrown in by taking that approach. It's kind of, rather than having to design a way to be scalable from scratch each time you develop something, you follow this pattern, and then if you need to scale it with modern cloud infrastructure, you can scale it, and you can scale it quickly. Is that a fair statement, do you think? Or
I think so. It's all about reuse. Reuse of technology. Who wants to write a web server when you can simply apt-get install Apache or Nginx, right?
Yeah.
Who wants to rewrite anything that you might find in the thousands, tens of thousands of packages available in Ubuntu? You use the word pattern. I think that's very applicable here, right? Who wants to design their own pattern for high availability and robustness when you would do much better to take one off of the shelf, when follow a well-trodden model that's known to work for Netflix or for Twitter or for Yahoo or someone like that. And so from that perspective, you're absolutely right. It's about reusing those patterns and reusing the technology underneath that helps you implement those patterns.
And so maybe then, could you talk a little bit about, so we have containers, and each container has, I think typically the idea is each container has some software in it that does one thing well, and as you say, if it stops working, you just kill it and fire up another instance. So now perhaps could you talk a bit about Kubernetes and orchestration of containers and what that brings?
But before we go there, actually, I'd like one other assumption that you made, which is absolutely correct for half of the container landscape, which is the container that does one thing and one thing really well, right? Those are typically process containers, and Docker is a great implementation of process containers. So inside of a process container, you take literally one Linux PID, one process, and you put it inside of that container, and you manage it. You move it around, you put resources around it, you put security controls around it, you scale it out, you scale it back, you migrate it from one machine to another. When something goes wrong, you kill it and start a new one. When you want to upgrade it, you kill it and you start a new one with the new code in it, right? That is, I think, that's a great overview of half of the container landscape, okay? There's another type of container which is used in a different way and should be used in a different way than the first. This other container is called a machine container. And it's actually a concept that predates process containers by quite some time. More into the cheroots and jails and zones and OpenVZ type approach. The implementation in Linux is something called LXD. It builds on the concepts of Linux containers, LXC. Inside of a machine container, rather than the goal being to run one single process, the goal is actually to boot into an operating system, okay? So that means that there are necessarily more than one process. The first process is sbin init, the boot process, right? And off of that process, you'll get an SSH shell and cron and add and a dozen or so sort of underlying plumbing that you need in any Linux or Unix system, okay? That container is a little bit, just slightly bigger than the process container, but it's still sharing the same kernel with the underlying. So it's just as fast and efficient as the process container, but it's used in a different way, right? It's used as a more general purpose system or machine. From that perspective, machine containers are often a good first step for someone or for an application into the world of containers, because you can very easily lift and shift any typical Linux workload that's running on bare metal or in a virtual machine and just put it into a machine container and it just works. Right? That's super powerful, and it's an important part again of the talk that I'll have on Wednesday next week.
And so again, showing my complete lack of expertise here, when people talk about Docker containers, do they cover both of those kinds of usage scenarios, or I mean, are there different technical choices people have to make?
Yeah, it's typically a different technical choice. So the Docker container is the process container. It's when you have an application and one application only that you want to run inside of that container. You need to design your application to take advantage of that container, because that container is not going to have SSH in it, for instance, right? So you cannot treat that Docker container, nor do you want to treat that Docker container like a machine, right? When you need to fiddle with something in a Docker container, you don't SSH into it, make a change, save it, and then then move on. Rather, you need to make that change somewhere upstream of that in your development process, and then redeploy a new Docker container containing those fixes, those changes. A LXD container is different. You would use it just like a machine. So you would SSH it, and you could apt install some software or fiddle with Etsy or add a cron job, for instance, git checkout and build, redeploy, for instance. They're different methodologies though, and it's important to use them properly, because if you go to a Docker conference or a forum and you start asking, how do I run cron inside of the Docker container, you'll be told you're not doing it right. If you come to LXD and you want you want to make it so that it's running just a single process, for instance, you're not doing it right. Use a Docker container inside of a LXD container, perhaps.
Yeah. Okay, and so can we then come on to the orchestration piece and what role Kubernetes plays in this picture?
Yeah, of course. So it's just it's a layer cake, right? It's a complex stack, as any operating system or technology is, right? Containers are fairly well understood now, but they're actually pretty low level. They're pretty fundamental inside of an operating system at this point. To do something useful with containers, at scale especially, to operate at a higher level abstraction or with more advanced constructs, you need something like a Kubernetes to orchestrate the containers that are going to need to run to make that system actually work and function. Okay, so just as a concept, right? You might imagine a website for uploading and sharing videos, for instance, right? Not that there aren't enough of those around, but let's imagine that you needed one of those, or you needed something like that, right?
Yeah.
You want to share cat videos or dog videos. There's not enough dog videos, right? There's plenty of cat videos out there, but you're going to start.
We've seen a gap in the market. Yeah.
Exactly. That's what the world's missing, right? So you could stand this up in a pretty traditional way. Get one big fat web server and write some Perl, CGI, PHP, whatever it might be, and put a big database, some storage behind it, and hope that one machine is big enough for all of your needs, right? That's probably good for you and your friends in the one dorm room. But let's say you're actually successful at this thing, and now you've got to scale it out. Well, that model provably just doesn't work. It's not going to work. It'll never work to scale out. So instead, if you take that microservices approach, right? Think about all the different services that you might need to run a website like that, right? There's the authentication piece, right? Because you log in and set your user preferences and profiles and change your password, right? In fact, changing your password could be a microservice all in itself, right? The process by which you send someone an email, you catch that link, they enter a password, you check that it meets the security standards, update the password, and then you're done. That's a good example of a microservice, right? And you could have one person or one team of people that work on that one microservice, right? Another microservice might be the upload process, right? There's a place where you upload the video and you need to catch that video on your back end and take some minutes about it. This is an Australian Shepherd running laps around a bunch of sheep or something like that, right? I like Aussies. I've got 2 Australian Shepherds, right? Now, what happens on the back end? Well, you've got to catch that video and transcode it, right? Because Safari needs different codecs than Chrome or Firefox. You also want to reformat all the videos to all the different sizes it might be. And each one of those transcode jobs could be a microservice.
Yeah.
All of this can be done inside of containers. You could have your web server and your password change process and each of your transcode processes. Each one of those could go into a container, right? Who's going to spin those containers up? Kubernetes. That's exactly what Kubernetes is meant for, orchestrating all of those containers and everything that it would take to stand up a system like that, for instance.
And does that then include, for example, sharing the load across multiple physical machines, or yeah?
That part's essential, right? I mean, you're going to want to spread that wide. In some cases, you're going to want to, load balance and put the transcoding happening on these systems where you've got some super fancy GPUs that can transcode efficiently. You don't want to overload one system, so you want to, spread out those jobs or spread those jobs across those systems. So yes, there is an aspect of load balancing, but you also have to think about, sometimes you want affinity. Sometimes you want things running close together, for instance.
Yeah.
Right? Maybe, for instance, that password change job, right? You might want that actually close to the database, because you're to read and write that data to the database. And if those are 2 containers running on the same physical system, you might actually be writing much closer or through the same cache to a disk or storage behind it. So yes, a good container orchestration system will be able to understand both of those, understand the affinity, keeping things close,
yeah.
as well as disaggregation or load balancing across nodes.
So it's kind of orchestrating in an intelligent way, deciding where to run things to give you the optimal results. And is it also then, I guess, as you said, it's load balancing. Is there anything else you then have to layer on top of that to get a set of containers working together?
Well, networking and storage. I mean, the networking amongst these containers is always fun and interesting and complicated. And then storage, persistent storage, right?
Yeah.
We can talk all day long about ephemeral containers and containers that they do something and go. Maybe they crunch some numbers or compress some data. And that's certainly true. The container itself goes away, the CPU and memory resources, maybe even the IP address. But the data coming into that container to do the compression or transcoding or calculation, and then ultimately the answer, the result out of it, needs to go somewhere, right? And that could be an object storage system like S3 or its equivalent in Azure or Google Compute, or if we're talking private cloud, it's OpenStack and Ceph or something like that.
Yeah.
You've got to handle all of those pieces. So just to unabashedly promote Ubuntu, we put everything you need to do all of that in Ubuntu. So you can launch Docker and LXD containers with a single command. Apt install LXD it's actually already installed by default in Ubuntu. So you can type LXC launch Ubuntu, and you end up with an Ubuntu instance like that. You could snap install Docker. And then Docker run, and you could run MySQL or MongoDB or Ubuntu, or if we were talking video transcoding, there's some fantastic stuff from NVIDIA that we've partnered with NVIDIA around for Docker and Ubuntu and NVIDIA hardware doing transcoding. So you're just a command away from launching those containers. But moreover, if you want to actually run a Kubernetes, you could actually, you're just a command away again in Ubuntu. Conjure up Kubernetes. And then it's actually conjure up Kubernetes -core is the one line you type. You wait 5-10 minutes and you've got a full Kubernetes up and running, at which point you've got as much hardware as you gave to Kubernetes, like a single server or piles of machines in Amazon or elsewhere. But then you can start, scheduling your workloads, and that might be a matter of using an existing Kubernetes workload or writing your own.
Right. And again, because I really don't think I fully understand any of this, would we, is it just something for production, or do you actually, does the developer on their machine, when they're creating the software, I mean, this is how I imagine it would work, use Kubernetes to orchestrate just on the local machine, and then as you move through the different environments, you continue to use it to orchestrate containers, but in different ways, perhaps, as you go into an environment where scale and resilience becomes more important.
Yeah, I mean, it always starts with the developer, right? I mean, nothing's going to go straight to production without a developer toiling on it for, days, weeks, months, years in some cases. From that approach, we've always taken a developer first mindset with respect to Ubuntu. We build Ubuntu for the developers, and Ubuntu-based technologies find their way into production, right? So you see that at like Netflix and Pinterest and eBay and PayPal and organizations that use Ubuntu at tremendous scale. It really started with a developer somewhere who had to get some work done. They found the tools that they needed to start doing that development. I think there's an entire class of developers today that are discovering Docker and LXD and Kubernetes on Ubuntu. They're doing their early work on Docker and LXD and Kubernetes on Ubuntu. We're starting to see the first of those make their way into production. But I think the tidal wave of Kubernetes-based services, this new wave of services, we're at the very tip of the iceberg there.
I suppose it's a very good point, isn't it, when you talk about maturity? So when I started developing, the idea of developing in assembly language was just something you wouldn't do. Do you see what I mean? And yet,
unless you had to.
unless you had to, you wouldn't do it through choice. But I remember reading that when C++ compilers first came on the market, many developers didn't trust the compiler to spit out good machine code, so they would rather write the assembly language. And I guess that's the point, isn't it? We will get a generation of developers soon coming through who have never had to scale or never had to do it in a different way, and won't, for them it will be the default choice for building something rather than a new approach.
That's true. I mean, honestly, that's kind of the secret behind developer velocity, right? You probably had to compile a kernel or two in your day, right?
Yeah.
What was the last time you compiled a kernel?
It's certainly over 10 years ago, yeah.
Exactly. Why? Because, Ubuntu and Red Hat and others just sort of do it for you,
yes,
and you get a kernel update sometimes. It fixes a problem. Hopefully you're keeping your kernel up to date and fixing security issues, but you're not building your own kernel so that you can run your own operating system at this point. And that allows you to go faster. That means that you can not worry about building your kernel. Instead, you can use you can just use a running system to then write your code in a higher level language, right? And you mentioned assembly and C and C++. Certainly today you'll find lots of Python and Go and Ruby and Rust and these sorts of things.
But I mean, even that, the amazing thing is, because I spun up an instance on AWS, and of course it comes with very little, but you're right, a few lines and suddenly you've got Ruby installed, or I installed Golang and MySQL, and I was amazed that something that even just a few years ago would have taken me probably a couple of hours of scratching my head and going, oh, what do I need to configure where? Here it felt like it was all being done for me. And as you say, that takes a whole load of plumbing and a whole load of stuff that isn't really adding any value. That it takes that out of the equation, so that as a developer you can concentrate on the fun part, but also the bit that's really creating something new. So yeah, it's a great point. And I suppose it does. Sorry, go on.
I think you're seeing that you're going to start to see that with respect to Kubernetes, right? Even just a year ago, setting up a Kubernetes was a very difficult prospect,
Mm-hmm.
you know. But now that's down to a one-line command that anyone can run on any Ubuntu 16.04 system, even in the cloud itself. You can run entire Kubernetes inside of a cloud of your choice, inside of a virtual machine on your Mac or your Windows machine. You're really just 5 or 10 minutes away from having that Kubernetes underneath. And from that perspective, I think we can actually start to focus on developers of apps as opposed to developers of Kubernetes and developers of Docker and LXD and the container systems.
And I think
that ecosystem is, I think that's the aha moment.
And I think that, again, it's coming back to what you said earlier, and I think it's come up in previous DevOps chats. There's a step change in containers with speed, but as you said earlier, actually a lot of the technology is not new per se, but what Docker and Kubernetes is doing is making it much more accessible, much faster for people to adopt and use. So it's a step change in that respect as well. As you say, if I only have to type one line, then I'm much more likely to do it. is the practical reality. So I mean, that's been absolutely fascinating. So just a quick reminder again, next week on Tuesday the 21st at 3 p.m. at Container World, you are running a workshop.
So workshop, myself and Marco Ceppi, he's one of my colleagues at Canonical. He's led our effort, engineering effort around Kubernetes. He's instrumental to that one-line deploy of Kubernetes. We'll have an entire room and a couple of people helping people out. We're happy to help you deploy a Kubernetes locally if you bring a laptop running Ubuntu. Or stand up a virtual machine on a Mac or a Windows system. Or perhaps ideally, if you've got access to a public cloud, we can help you get a Kubernetes running in a public cloud as well, which certainly has the advantage of being able to share it with your colleagues, with your department, if you're going to take that back to work with you.
Fantastic. That sounds awesome. And then the next day on the 22nd at 1:30, and I think we've touched on some of what you will be talking about. You're talking about the right tools for the right job, yes? Yeah.
So I've got a 45-minute talk on Wednesday, 1:30 p.m. Using the right tools for the right job. So at this point, there's a lot of different ways of using containers. It's sort of a survey of some of those and how you might use them, when you might use them, where you might use them. I'll try to keep it as fair and objective as possible. There's a lot of different options available in Ubuntu, and we build Ubuntu to be the platform of choice. So we want to give you all the choices you need to make the right technical decisions necessary, and we do that in the hopes that Ubuntu continues to be a popular platform for developers.
Fantastic. Sounds awesome. And of course, looking forward later this week to have you online for the Twitter chat itself.
And when's that?
So it's 8 o'clock UK time. So that's going to be 2 o'clock, I think, for you. But I'll send you an invite.
Okay.
But again, I've learned a lot. It was really interesting talking to you. Thank you so much for spending some time with us, Dustin, and yes, see you on Twitter and have a great time at Container World.
Great, thank you.